All right, it's good to see most people came back. That means yesterday was a successful day. So my name is Michael Minella. I work for Pivotal as one of the Spring engineering teams. I'm the project lead for Spring Batch as well as Spring Cloud Task. I also work on Spring Cloud Data Flow and a few of the other projects, author, speaker, et cetera. Two plugs I want to give at the beginning of this. First of all, a personal one. I'm a member of a podcast called Offheap. It's a pundit podcast for technologies around the JVM. So if you want to hear a bunch of guys at a bar talking about Java EE, Oracle v. Google, and those types of things, check it out. It's at Offheap on Twitter as well as javaoffheap.com. The second plug is Spring.io, Spring.io platform. That is the big Spring conference that's held annually. This year it's at the beginning of December. It's going to be held in San Francisco at the Moscone Center. On the back of the card that you received with the Wi-Fi information in the map, there is a coupon for $500 off a full price admission. So if you have any interest in that, go ahead and check out Tasha and Kieran. They're raising their arms right now. If you have any questions about that, highly encourage checking it out. That's when basically all the big releases and all the big news about Spring each year happens. Everything I'm going to talk about, code, presentation, it's all already available on GitHub, so don't worry about writing anything down. I see people with notes in that. Don't worry about it. And don't be shy about questions, whether it be during the talk as well as afterwards. I'll be around all day. Let's get a lay of the land really quick. I'm assuming since this is Spring days, everybody's comfortable with Spring Framework. Quick show of hands. How many people have used Spring Batch before? Sweet. How about some piece of Spring Cloud? Okay, still a good set. Spring Cloud Task. That's kind of what I expected. And then Spring Cloud Data Flow. Okay. So we heard about a lot of really cool technologies yesterday. Some Java 9, some reactive stuff. But I'm here to talk about the most sexy technology you're going to hear about this entire conference, batch processing. And while it's an old technology, I mean, let's be honest, the invention or the origination of processing on computers began with batch processing, it is still a very relevant processing model in today's enterprise. There are still mainframes out there. There are still finite workloads that are happening. Data science, all these types of things still fall really nicely into the batch processing model. And with modern tools and technologies, we can actually modernize these processes into more powerful tools. To do this, we're actually going to build a bit of an app today. We're going to walk through iterations of it as we apply these different concepts. And what we're going to do is we're going to take files from S3, and we're going to import them into a database. So if you're familiar with traditional batch processing, the idea of grabbing files off an FTP server, slamming into a database, this is the idea. This isn't intended to be a difficult or confusing application. I don't want you to worry about the domain model, so you'll see it's really, really dumb. But the idea is to see the tools and how they interact. We're going to use Spring Batch as kind of the baseline for the batch processing technology. And this is, for those of you who aren't familiar with Spring Batch, this is a technology that's been around for almost 10 years, 10 years-ish. So, and it's used in just about every vertical in just about every industry. So this is battle-tested, well-used framework. The current version that's G is 307. We're currently working on Spring Batch 4, which will come out later this year. Now, the 3.x line is kind of dated. The last time it came out was 2013, 2014, somewhere in there. To give you an idea of what was new back then, the iWatch was new. That was the big announcement at WWDC that year. Heartbleed was also kind of the big rage as far as security goes. Everyone's probably thinking, like, when was that even? A bigger issue, though, is Spring Boot didn't exist yet. That was the year we actually announced Spring Boot. And if you think about how Spring applications have been transformed by Spring Boot, there's a bit of a difference between the way you write programs before or software before Spring Boot versus now. So the Spring Batch 4 is really the first major version that's going to be released post-Spring Boot. So we're taking the opportunity to improve features so they play nicer with Spring Boot. Specifically, we're upgrading to Java 8. If you're running batch processes, you may already be running on Java 8, and that may not even impact you. Most of the features that Java 8 provided, like lambdas and whatnot, already work fine with Spring Batch. But for us internally, Spring Batch 3.x supports all the way back to Spring Framework 3, which is either Java 1.5 or 1.6, I forget which. So our code internally is still very 1.5, 1.6-ish. Like we haven't used lambdas. Even the diamond operator is new in our code. So we're taking this as an internal opportunity to basically rip out all the code that we don't need and then bring it up to snuff. Obviously, we're also upgrading all the dependencies. That's standard for any of ours, including we're going to require Spring Framework 5. So all the new features that are available within Spring Framework 5, the pieces around Java 9 and all that, we're going to get all of that from Spring Framework 5. And the last piece is we're adding a whole bunch of new configuration options, builders and whatnot, to ease the Java configuration process. Right now with Spring Batch, a lot of the, both the documentation and the configuration options are more biased to the XML world. We're changing that with this release to make the Java config story a much better story. So looking at our batch process that we're going to build. Again, like I said, we're going to use Spring Batch 4 for our process. If we look at this from how this process is going to lay it out, like I said, it's a really stupid process, but it should illustrate what we want to talk about. It's going to be a single job. We'll call it S3 JDBC job. It's going to consist of a single step that's called load. And within that step, it's going to have three components. It's going to be a chunk-based step. So it's going to have a reader, a processor, and a writer. And the reader is going to be the flat file item reader, probably our most traditional reader. It's going to read a CSV, a flat file. It's going to have an enrichment processor that's going to call a REST endpoint. And again, that's just going to return a dumb string that counts how many times that it's been called. And then we'll use the JDBC batch item writer to actually persist the data into the database. Does that make sense? For those of you who haven't seen Spring Batch before, let's take a quick look at what that looks like. So I'll start off with the Spring Batch piece of it. This is a boot application. And so this class should look familiar to everybody. This is how you bootstrap Spring Boot. Nothing interesting there. Let's go to the job configuration piece. This is where things are interesting. So actually, I should point out one thing. So here I've got my enable batch processing. That enables the magic within Spring Batch. It basically bootstraps all of the infrastructure that Spring Batch needs. When we go to the job configuration, I'll start at the bottom. I need a REST template to make those REST calls. Spring Boot would provide that for me out of the box if I wanted it to, but you'll see later on during the talk, this will actually become important. I've got my job configuration, so it's just a simple job builder factory.get the name of the job. I'm using a listener here. This is going to download the files from S3. So when I start my job, it'll look for the files on S3. If they're there, it'll download them for me. This allows me, if I'm running on, let's say, a Cloud Foundry environment where you don't have persistent disk, if I run this job, it doesn't matter because every time I run the job, it's going to check and download those files again. I start at my single step, and then I call build. The step here is about as simple as the job. So I've got step builder factory, got the name of the step, which is load. I'm going to chunk size at 20, so that's how many records I'll process within each transaction. I've got a reader, a processor, and a writer, and then I call build. The writer here is my JDBC batch item writer. So all it takes is a data source. I'm mapping them via bean properties. So each one of the values is going to be determined, or basically first, second, third, and message have getters and setters on my domain object that I'm going to be using. So I don't need to configure anything else as far as mapping my domain object to my SQL statement. There's my SQL statement, .build. I've got a processor, which we'll look at in just a second. Then I've got a flat file item reader. So again, new flat file item reader builder, name. It's a delimited file, so I call .delimited. I define what the names are for each one of the columns within the CSV. The target type, so what am I going to map this to? In this case, it's an object called foo.build. Now, if you've used Spring Batch before and done Java config, this flat file item reader, the builder should, that's a new feature in Spring Batch 4, and the equivalent of this in the old version is about 15 lines of code. So dropping that down to about 5 is what we're looking for. We're going to load multiple files, so I'm actually going to have a multi-resource item reader. So what this is going to do is it's going to go through each one of the files, and as it finds a new file, it'll delegate that to the reader we just configured. So I create my new reader. I delegate to the delegate, which is the flat file item reader we just looked at. And then this is all just getting the resources that I'm going to download. That's really it. We can take a look at the processor really quick. The processor is going to be, like I said, that's the piece that's going to call that REST endpoint. And so it's just doing REST template.exchange, my URL, which is localhost 8080/enrich. It's doing a get. I'm not passing it anything, and I'll get a string back. I set the message on what I get back and return it. So about as straightforward as you can get. On the REST service piece of it, this is the controller for that service. Again, it's about as simple as you can get. Get mapping /enrich. I'm just going to have a counter that increments each time it's called, and I'll return the message enrich with the count. Does that all make sense? Now let's build it and run it really quick. Let's build. So first I'll start the REST service. And then also just to show that I've got nothing up my sleeve, I'll grab MySQL. Let's do this. You can see there's no table or anything already created. My process will create all of this for us. So let's go ahead and run the job itself. Oops. So you can see it ran. The job was complete. And let's go ahead and take a look again. Again, this is about as simple of a job as you can get. It imported 2 files. First, second, third were the values that came from the file, and then the message is what came back from the REST endpoint. Does that make sense to everybody with regards to just what happened? OK. Now, we talked yesterday about, I think Josh and Mark talked about how we all don't write bad code. We don't write code that has exceptions. Nothing ever goes wrong with any of our processes. But when it does, there are tools within Batch as well as the other cloud pieces that help you handle those error conditions. Spring Batch itself has things like skip and retry that allow you to handle records that are faulty. So if I have an exception that's thrown, I can skip the record, I can retry it, and those types of things. Those are already built into the framework. You don't need to do anything else. But one of the newer things that is coming with the upgrade of dependencies for Spring Batch 4 is the addition of a circuit breaker. So traditionally, when you had let's say, an exception that you wanted to skip that was embedded in a chunk of items, what actually happened was we rolled back the transaction and reprocessed all those because we want to be able to identify which one was the one that caused the problem. That is actually a rather heavy process to have happen. So if you want to kind of short circuit these things, and you can just write them out or flag them in a different way, the circuit breaker pattern is a little easier way to handle that. Now there's a few different options within circuit breakers within Spring portfolio. You've got Hystrix, which is from Netflix, and that provides a whole nice dashboard, and you can toggle them via the dashboard. Plus there's all kinds of more robust options with regards to when to flip that circuit back. But the one we're actually going to use is provided in Spring Retry. Spring Retry is a small library that it provides retry capabilities. And with the latest version, they actually have a circuit breaker implementation in there. Let's take a look what that looks like. Unlike Mark and Josh, I don't live code. You guys would hate watching that. So this is the same batch application. The only difference now is the processor. So the processor before was just essentially this process method before. Now, with the updated version of Spring Retry, I have the idea of a circuit breaker. And so to implement that, I start off by adding the circuit breaker annotation. So this is the method that I actually want to wrap within a circuit breaker. I then add this other method called recover. And recover essentially requires the same signature as the circuit breaker one. And what happens is when an exception is thrown by the circuit breaker method, the recover method is called. And when that happens, it will flick the circuit breaker essentially to closed, so that that method will be called for a certain period of time. By default, it's a time-based retry. So what we should see happen is if the REST endpoint throws an exception, that won't be called every time. It'll be called a couple times. And the circuit breaker will automatically run this recover method for the times that it doesn't automatically go to that. Yeah?
Can you do multiple fallbacks?
With
So, like the recover, let's say it may call out to like set a hash or something, and that failed because the hash isn't available. Can you do like another fallback after that?
With the Spring Retry, you can't. I don't know about Hystrix.
You can.
But there you go. You can use Hystrix with this. This is just using the retry because you don't have to add anything else for this. So that's really the only change I've made to the batch job. The only other change I made for this right now is the fact that now we're actually going to randomly throw exceptions from our REST endpoint. So half the time I'm going to throw an exception that says, hey, I screwed up. The other half I'll actually return the item. So what we should see, now keep in mind this is random, but what we should see is some of the messages in that enriched column in the database when we run this again, some of them will say error, which is what my fallback method does. So my fallback method just sets it to error instead of what was returned. And what we also should see is that we should see less exceptions than number of errors in the actual in the table, because that means the circuit breaker is actually kicking in and not just letting that exception happen each time.
Question.
Shoot.
So the REST point kind of exposes data from memory, I'm assuming, right? I mean, what happens if the instance goes down?
So in this case, so the question was, what happens if the REST endpoint goes down? In this case, the circuit breaker would kick in because it would still get an exception, and it would call the recover method. So whether the REST endpoint is running or not, the recover method would be called. Does that make sense?
Yeah, no, maybe I lost my question there. The REST point is to expose the data about the batch that is running, right?
Yeah, it's enriching the model. Think of it as it's not exposing anything for the batch process itself. The batch process itself is processing data from a file,
Right.
and then it's getting additional data from the REST endpoint.
Okay. And what if the batch goes down, essentially? Can it restart from?
You can use, Spring Batch provides restart ability all built in. That's part of Spring Batch anyways. Let's see. Let's go ahead and run these again. Start the REST service up. So again, the job completed. If we look over here, we can see that the exception was thrown. Let's see if we can figure out how many times it was thrown. It's a little hard on this screen. There's once. There's twice. 3 times. So it's thrown 3 times. Let's take a look at what the actual results were. So you can see the exception was only thrown 3 times. So the REST endpoint was only called 3 times that actually errored out. But the circuit breaker took care of the other times for us, assuming that it would have errored out, giving the REST endpoint time to essentially recover. So we actually had 1, 2, 3, 4, 6 out of the 8 records were populated by our recover method. Does that make sense?
What if they have exception in recover?
So that goes back to what the other gentleman was talking about. So the question was, what happens if there's an exception to recover? essentially that would fail the job as it sits right now. But if you were to use something like Hystrix, you could have additional fallbacks. Or you could also, at that point, configure with Spring Batch the full skip and retry logic there if you wanted. That's up to you. That makes sense? Cool. Shoot.
Does the file size matter?
File size? No. Yep.
I'm running a batch on a Cloud Foundry with great chunks of interest in the file. If the file is so huge, is it downloading the whole file or reading the chunks where I can kind of
So the question was, basically, is there a limit on file size, and how do we manage them locally? With the Cloud Foundry specific piece, you'd have to chunk it up because there is a limit on the file size. But right now, because I'm running all this locally, I'm just downloading the whole file. So right now, everything is configured via traditional Spring Boot processes. I've got an application.yaml that has all of my configuration. So my S3 configuration, my database configs, all that type of stuff is already embedded in my application. And that isn't a very cloud-friendly way of doing this. Not only am I not showing you that file specifically because I don't want my S3 creds recorded and blasted everywhere, but also it's just, that means if I publish this artifact, the creds are there, and all those other security concerns and whatnot. So there's multiple approaches to handle this in a more cloud-native way. First of all is the Spring Cloud Config Server. So Config Server allows you to expose configurations using the traditional Spring properties and environment abstractions that you already use, just using a remote config server as opposed to a file somewhere. The other option is Eureka. That allows you to do service discovery. So in this case, we actually have two different pieces of configuration that that we care about. One is our database, so how do we talk to that? The other is how do I talk to that REST endpoint? We'll use config server to configure the database credentials and the S3 credentials, those types of things. But how to find that REST endpoint, we're actually going to use Eureka. So what will happen is the REST endpoint, when it starts, it will register with Eureka. Eureka will then know where to talk to and how to talk to that REST endpoint. Our batch job will then ask Eureka, hey, I need to talk to this REST endpoint. Where is it? How do I talk to it? Eureka will provide that information, and the batch job will use that. So really, this looks kind of like this. So we've got S3, my import process, the database, and then you've got the config server will be used directly by the job, and then Eureka will be, the REST service will register with Eureka, and the import process will use the information from Eureka to know how to contact the REST service. So this is the version of the cloud native one. So my job itself hasn't changed. There's really no additional changes here, except for one. Remember I said me configuring the REST template was actually important? It's because I want to add this load balanced annotation. This essentially gives me a Eureka-capable REST template. So now it will use Eureka behind the scenes to determine how to talk to the service as opposed to me manually configuring the URL. And if we go to the processor, instead of having localhost 8080 here, now I just have the name of my service. So I don't care where it is, I don't care the port, URL, any of that. Now all I need to do is reference REST-service, and the Eureka-enabled REST template will actually then know to translate that with the values it gets from Eureka. From a configuration perspective, I need to swap this out. That's going to be a problem. I think that's dash I did. was what I wanted. Yeah. Let me talk through this as opposed to running it. The stash I did at the very beginning is the config file I needed. Sorry about that. So in order for this to work, I've added a couple additional things. I've added enable discovery client. This is what is going to essentially allow my batch job to talk directly to Eureka, as well as the dependency. And then, like I said, in my configuration, that at load balanced is what gives me the Eureka server specific version of the REST template. Does that make sense? Correct. So, and actually, good point. So you just mentioned that the config server piece, that actually I don't need to do anything for. All I need to do is have it on my class path. So I've got, where's it at? It started config. So having this dependency gives me the config server stuff there. So it will automatically start up and grab the configuration directly from that, assuming it's configured correctly. The last piece of this puzzle is how do we scale the application? And scaling in Spring Batch, there's really 4 different options. The first one is parallel steps. So right now we have a single step job. So there's really nothing to parallelize here. But let's say I wanted to import 2 files that were completely unrelated. I could have those 2 steps running in parallel with no problems. The second option is multi-threaded steps. So here, when you're executing chunks, I could execute each chunk within its own thread. So I can be processing chunks in parallel. The third option is partitioning. So this is where I take a large data set and chop it up into smaller chunks and process those in parallel. There are 2 different versions of how to do that within Spring Batch traditionally. One is using threads within the single JVM, and the other one is remote partitioning. So here I've got a master and a bunch of workers that are listening for that partition metadata. So that partition metadata is really just what records am I going to process. So that can be the name of a file, that can be a range of IDs from a database. But traditionally, the way that's been set up is you've got the master and a bunch of workers, but the workers are sitting out there essentially forever, waiting for this work. So it's a very non-dynamic process. The final option is remote chunking. So with remote partitioning, each one of the workers is responsible for doing the work. They do all their input, they do all their processing, and they do all their writing. They are independent of the master, really. Remote chunking is a little different. Remote chunking, the master does the reading, and then it sends the data over the wire to the workers for processing and potentially writing, or you can send it back to the master for writing. Remote partitioning is typically when you are I/O bound. Remote chunking is if you're process bound. So if you're doing some type of complex processing algorithm or something like that, that's the bottleneck. Remote chunking is the way you would scale that piece. We're going to use partitioning for this, because really the processing piece isn't the bottleneck here. And it actually, the way we're doing this lays out nicely with remote partitioning, because we have multiple files, and so we can just have each worker process a different file independently. But we're going to do this via Spring Cloud Task. And what Spring Cloud Task does is it allows for more elasticity in that model. So here, I've got the master. It's going to pull down the files from S3. It wants to kick them into the database. Once the master knows what files to download, it's going to then send out essentially the URL to each file to the worker. The workers are then going to download the file and process it. So each worker is going to get essentially a URL for a unique file. It'll download the file, process it, and import it. The important thing with Spring Cloud Task here is that instead of each one of these workers being sitting out there waiting for work, it's actually going to launch these as independent JVM processes. So if you're running on Cloud Foundry, these would be run as tasks on Cloud Foundry. The idea here is you get that elasticity. When you start the job, there are no workers running. When you get to this step, the partitioner determines how many workers you need. The partition handler launches those, And then once those are complete with their work, they shut down and the process continues. So you finally get that cloud-like elasticity within your batch process. So for here, the only thing I had to change is my job configuration. And I had to configure the pieces that a partition step uses. So the partition step uses two different pieces. It uses a partitioner, which is responsible for saying how to communicate to the workers. So traditionally it's been either threads or, partition handler is responsible for communication to the workers. So it either is via threads or message-based, or in this case, we're using the new Spring Cloud Task one that knows how to launch those independent workers. So that's the partition handler, and then the partitioner is responsible for knowing about the data. So in this case, Spring Batch comes with a partitioner called the multi-resource partitioner, and basically it creates a partition per file, which is what we're going to use. So I configure my master step. So instead of the single load step, now we've got a couple step definitions. The master is what's going to replace that load step, and it's responsible for managing the partitioner and partition handler. So the partitioner is going to be, again, what's responsible for chopping up the data, and the partition handler is the piece that knows how to communicate with the workers. You can see in my job, I've changed it from the step from load to master. So my job only knows about the master step. My partitioner, I'm using the multi-resource partitioner that comes with Spring Batch. In this case, all it's doing is it's getting a list of the resources, in other words, the files. And it's going to create, when it's called, a partition per file. The other piece here is the partition handler. And this uses something within Spring Cloud Task called the deployer partition handler. What this does is it uses a deployer, which is called a Spring Cloud deployer. This is a piece of code that knows how to deploy tasks on the various cloud-native platforms. So Kubernetes, Mesos, Cloud Foundry, Yarn. So it can launch short-lived processes on any of those platforms. So I configure this to be use whatever deployer I want. In this case, I'll be using the local deployer since I'm running things locally. But here I say, what are my command line args for the child processes? I don't want to pass in any environment variables. I configure the max number of workers. So let's say I get a partitioner that returns 1,000 partitions. I don't want to actually launch 1,000 workers. So I set a max there. So in this case, it's just 2. An application name, and I return that. The worker configuration is essentially what used to be the load step in the job. So it's got the reader, the processor, and the writer, and that load step. Does that make sense? So the question is, do I have multiple workers processing the same resource? No, so what this does is each resource, or each worker will receive a URL that's specific for its resource. So basically I'm saying you process file 1, you process file 2, you process file 3, and so forth. Correct. Yeah, it does not break up one large file. Yeah.
Mike, you said each of these workers is a separate JVM. Is it a separate JVM be on another machine or in another area? It doesn't have to be on the same physical machine as the Spring Task?
So the question was, does the JVM have to be in the same box? And the question is no. That's where that whole deployer abstraction comes in. So if you're using Cloud Foundry, it'll essentially does the CF push for you with the jar file that you want to run. And Kubernetes, it'd be a Docker image and so forth. Does that make sense?
Same response and they agree before continue processing, or it's always each one goes to a unique one partition to task?
So the question was, is it capable to run the same partition essentially multiple times at the same time? The answer is no. There's reasons for that. You mentioned that, like cross-checking and that kind of thing. The issue is by doing that, we impact like restartability. So the whole idea of these partition steps is each one has its own step execution, which is how Spring Batch tracks the state of a step. And when, if I were to pull a plug on a batch job, the state is there. When we restart it, any partitions that are considered complete, we don't restart. Any ones that are halfway done, we'll restart at the right spot, all that kind of thing. Now that doesn't that doesn't prevent you from using or doing essentially the same thing within that worker step. So if you wanted to do those types of things, there's nothing stopping you from writing that yourself, but there's nothing within the framework that does that.
Are you assuming a fixed cluster size, or can you discover new workers and then when they become available and start up? Because we're looking at elasticity, right? So we're going to save costs when the batch is not too high to pay. Yeah,
so the question was, can you, essentially you grow the cluster as it's running? Is that a? Yeah. So no, so the way it works right now, the cluster size is fixed once that step is running. That being said, I haven't played with it, but we're looking at using something like config server to be able to automatically refresh that value to allow that type of, and if we can do it with config server, then we'd be able to open up to other abstractions. But the idea of allowing essentially you to process more partitions than you want is something we're looking at. Yeah.
Can a partitioner select certain partitions not to be processed, like unusually?
So the question was, can I select specific partitions to not be processed? That's the responsibility of the partitioner. So if you wanted to not process certain partitions, that would be a customization within the partitioner that you would write so that it knows to exclude that data from your partitions. Yeah?
Does Spring Batch provide any support for catching like the signal abort from Cloud Foundry or whatever to gracefully shut down?
So the question was, does Spring Batch provide facilities for a graceful shutdown from a SIG term or something like that?
Yeah.
And yeah, so that's actually baked into Spring. If you do a SIG term on a Spring application, a gentle one, not a kill -9 kind of thing, then yeah, it should shut down gracefully and the state should be persisted accordingly.
I have a question. So when it comes to making a web service call to update some state of the object into an external system, what's the best place to make a web service call? Is it like processor or it's the writer?
Let's take that one offline.
Sure.
Yeah, so the question was, does Spring Cloud Task work with Spring Batch? Yeah, they're actually complementary. So those worker processes are actually Spring Cloud Task processes. So that was the one thing I didn't show in the code, which I probably should have. To get all that goodness, that's right there. So the last piece of this puzzle is, how do I orchestrate this stuff? Obviously, up to now, I've just been doing java-jar, the name of the jar file, right? Not a very elegant solution. And so in a cloud-native world, we've got Spring Cloud Dataflow. And what Spring Cloud Dataflow is it's essentially an orchestration tool for data processing microservices. It provides a UI, it provides an interactive shell, it provides all the monitoring and whatnot to launch, monitor, restart, stop, all those types of things, these batch processes. I can quickly show you what Spring Cloud Dataflow looks like. That won't matter. Oops. So just like everything within Spring Cloud, it's all just a boot jar. So Spring Cloud Dataflow, the server is just a boot jar, as well as the shell. So that's up and running. So this is the interactive shell. I can hit tab and it'll tell me what to do if I don't remember. So essentially the way this works is you register an application. So I say what the application, give it a name, what type it is. So source processor sync, that's on the streaming side, as well as task, that's on the batch side. And then a URL. The URL can be file, Git, Maven, HDFS, basically anything that the Spring Resource Abstraction supports. From there, I can launch it via basically task, launch, and the name of the definition. On top of that shell, we also have, oops, a UI. So really quick, just to run through it, we've got an app for tab for apps. So these would be all the apps I've registered. You can register them here as well, or in the shell. Runtime. So if I had applications actually running, this would be a list of all of them, the number of instances and that type of stuff. You could actually drill into properties as well. On the stream side of things, which I believe is actually going to be covered in another talk sometime today, here you would see the definition of your streams, so source processor syncs, as well as there's a cool UI that you can actually drag and drop things and construct your streams dynamically. Batch jobs within Spring Cloud Dataflow are run as tasks. So I would see all of my definitions here as well as my apps. And then also there's this executions tab, which is essentially a UI into the database recording of all of the task executions. So when a task runs, it records the start time, the stop time, the name, all that kind of stuff, the results, if an exception was thrown. So all that would appear here. Spring Batch within a task is a common use case, so we've got a tab specifically for jobs. Again, the same thing, it would show the start time, stop time, the number of steps that were processed, the number of records that were processed, all that kind of stuff. Finally, we've got an analytics tab if you want to do some analytics. That's really it. So the question was, can you schedule the job to run? Currently, there's nothing within Spring Cloud Dataflow itself to do scheduling. We're actually looking at, get you in just a second, I do see you. We're looking at a couple options. So number one is providing the ability to use whatever platform you're using. And the scheduler built into there, so like Kubernetes has a scheduler, Cloud Foundry is getting a scheduler, that kind of thing. As well as currently you could do scheduling with essentially writing your own source or whatever and having that kick off events. That would kick off tasks. Sorry, I didn't get that. So yeah, you could use, so all of this interacts with a REST endpoint, so if you can do anything that will call a REST endpoint, so cron can call a script that calls a REST endpoint, that would work. Quartz is another thing you could use. In the back?
My question is regarding integration with Kafka or SNS or SQS. Can you feed your item reader off of that? Other than just scheduling certain more dynamic. Is there anything out of the box that provide that?
So the question was, can you integrate with messaging systems to launch specifically or as a source of input?
Source of input and also to let's say if you weren't in an environment where you would have a container service like Docker or OpenShift or Kubernetes, can it offload to like another way of sending those messages downstream to be handled?
So you can definitely use, there is actually a JMS item reader, and you can also write other item readers that could use it as that type of data as a source of input. You can also, we have components for launching tasks from messages as well. So if you wanted to just send a message that would kick off a task, which contained a batch job, you can do that as well. That's really...
Question in the back.
Sorry.
Real quick. If I'm doing more traditional batch, not necessarily cloud-enabled, can I use the Spring Cloud Dataflow UI as the replacement for the Spring Batch admin? Sorry.
Grab me afterwards.
Okay.
Evading the question. Who else has got a question?
In the back.
So how big is the change from Spring Batch to cloud native application? Because most of these are implemented in a company using the Spring Batch. So how big is the change? Is only the configuration level or like the things what you showed, or is it a huge change?
So the question was, how difficult is it to change a current batch process to a cloud native one?
Yes.
And it really is the pieces that I've shown you. If you have, especially if you're already running them via a Spring Boot, it really is just swapping out those different pieces. If you're not running Spring Boot, which I see you shaking your head, that becomes a little bit more of a challenge. I'd recommend moving to Spring Boot. The question there becomes a deployment model. Are you going to run on something else? You can. Obviously, Spring Boot supports packaging up applications as a WAR file, and you can do that. It becomes a little more interesting, though, if you're going to run a process that's intended to be short-lived in something like a servlet container. So that's where things kind of get a little dicey. I think I'm getting the hook.
No,
so.
you continue to take questions while we get the next laptop set up. We're going to take away your nice slide, but we'll keep asking questions. Any more? He's evaded 2, so we're going to have an open space on Spring Batch, clearly. Another one in front.
You mentioned about the Eureka server, where the batch job is running and which is discoverable, and it can invoke the REST service, which is also registered with the Eureka. What if my batch job is not discoverable on Eureka? Some middleware or a JMS process, which is a legacy one, which is still not migrated. But my REST service is on the Cloud Foundry, and it is registered with the Eureka or the service registry. So is there a way for the request to route it through the Eureka? Because it is, my provider is already registered on the Eureka.
So let me see if I got that right. Your batch job is running off of the cloud,
It's not a Spring Board, it's some legacy batch job.
Okay.
And it needs to invoke the REST service, which is on Cloud Foundry and which is registered on Eureka.
Yep. So there's nothing stopping you from having external services talk to Eureka.
Oh, we can do that?
Yeah, you don't have to be. So if you have Eureka running on Cloud Foundry, there's nothing stopping just a server running alongside, just on bare metal, talking to that Eureka instance.
Okay, so you can still go through that.
Yeah.
Cool. Everyone, round of applause for Mike.